Let us look at backreferences. The groupings we saw earlier are also known as capture groups. The text captured by such groups can be referred later using backreferences. And these backreferences can be used both in search and replacement sections. So this is the grouping syntax which we have seen earlier. If we add a percentage prefix to the opening parenthesis, then it becomes a non-capturing group. We'll see examples for both of these. To refer to these capture groups, we can use 1 to 9. The leftmost opening parenthesis is given the number 1. Second leftmost opening parenthesis will get the number 2 and so on. To refer to the entire matched portion, you can use \0 or ampersand. Let us look at some examples. If you recall, \a is a shortcut to alphabet characters. So if we put this inside a capture group and then immediately follow by \, and 1, this will help us to match consecutive repeated alphabets. So let's type that. \, and lowercase a refers to alphabet characters. And now let's capture the text that is matched by \a. To refer to the exact character matched, so \a can match 52 different characters, but we want the exact character that is matched because we are looking for consecutive repeated alphabets. So we can refer to this particular character that was captured by using \1. So you can see a few matches here. Lowercase e 2 times, uppercase t 2 times, and so on. The case also has to match. We can apply quantifiers to these backreferences as well. So suppose we want to replace all such consecutive repeated alphabets, then we can use, so within capture group we have \a, and when we specify the backreference, we can also add the quantifier plus. So this particular backreference has to match 1 or more times. Let's say we replace it with 1, 2, 3. So these 3 matches should be replaced with 1, 2, 3. Next, let's see an example with referring to the entire matched portion. So in this case, we don't have to specify a capture group. So suppose we want to surround numbers with parentheses. So to match 1 or more digits, you can use \d and the plus quantifier. And now we can replace it with opening and closing parentheses, and in between the entire matched portion, which may or may not have other capture groups. So whatever text is matched in this search pattern can be referred by using the ampersand key, or you can use \0. You can see numbers have been surrounded by parentheses. Next, let us see how to swap words that are separated by a comma. So to match word characters, we can use \w. So word characters are alphabets, numbers, and the underscore character. We want to match this 1 or more times, and there are 2 words that are separated by a comma. So this helps us to match words separated by a comma. We want to swap them. So we need to capture these 2 words separately. So surround them by a parenthesis and another capture group here, and in replacement, so this is the leftmost opening parenthesis. So this is capture group 1 and this is capture group 2. We want to swap them, so we'll say \2 comma \1, and such words can occur more than once in the line. We'll use G flag. Let's see the result. So you can see words have been swapped. Let's undo. Next, suppose I have a input string like this. There are certain sequence of characters that are surrounded by a single underscore, and sometimes there are double underscores. I want to replace two underscores with a single underscore, and if there are only one underscore consecutively, then I just need to delete them. So I can optionally match an underscore character and then match one more underscore character. So this will effectively match underscore once or twice. If it is twice, then this capture group will have a single underscore. If it is matching only once, then this will be empty, even though question mark is a greedy quantifier. Because overall pattern has to be satisfied, this will become empty. So we can refer to that position in the replacement string. So double underscores will become a single underscore, and if there is only one underscore, this will be empty, so that gets deleted. Let's do that. Next, let us see an example with non-capturing group as well. So suppose I have numbers that are separated by one or more occurrences of ABC. So this particular ABC sequence is repeated one or more times. So I want to match such a sequence, that is numbers separated by one or more sequences of ABC, and in the result I want to put this second number first, use a colon character, and then put the first number next. So let us see how we can use capture groups as well as non-capturing group. So we know we have to match two sequences of digits, and since they are going to be swapped, we can capture them separately. In between these two digits, we have one or more ABCs. So since ABC is more than one character, we need to apply a grouping to be able to specify a quantifier. This particular text is not needed in the output. So we can prefix a percentage to the opening parenthesis so that this portion is not captured. So now this is capture group 1, this is non-capturing group, and this is capturing group number 2. So in the output we can say \2 colon \1, and that's it. So this particular text should get changed to 24 colon 12. Let's undo. Instead, if you had used a capture group for this portion as well, then this becomes capture group 1, this is capture group 2, and this is capture group 3. So the replacement section will require \3 colon and \1. So which one to use depends on your preference, but the general rule of thumb is if a particular portion is not needed in the replacement section, you can use a non-capturing group. Next, let us see what happens to a capture group on which a quantifier is applied. When you back reference that particular group in the replacement section, you will not get the entire match that is matched by this group and the quantifier. So let me explain that with an example. Suppose I have a string like A space and then some digit characters. I want to match 3 digits at a time, one or more times, and then my aim is to surround such sequence of digits with a parenthesis. But first we'll see what happens if you just naively try to use just a single capture group. So my text has A followed by digits, but I want to match only in groups of 3. So instead of plus quantifier, I can use exactly 3 times. And this grouping of 3 digits can occur 1 or more times. So I need a group so that I can apply a quantifier on that. So now I want to replace A with B, and whatever digits are matched here, I want to surround them within parentheses. So inside this I need to refer the text that is matched, right? So usually you will just use \1, but this will not give the result which I need. So this particular text, I want to change it to this output. But if I use this regular expression, I'll get this output. So why is that? Because this particular quantifier is outside the group. So first time these 3 digits are matched. This is a greedy quantifier. So what will happen? It will also match this particular sequence and then this sequence as well. But in the regex search pattern, we have only one capture group. So first time it has 1, 2, 3. Next time it has 4, 5, 6. And the third time it has 7, 8, 9. So once all this is done, when you use \1, you will just get 7, 8, 9. So what is the solution? We need to use a capture group on this group as well as this quantifier. So now let's get the previous substitute command and let's apply a grouping to cover both this inner group and the quantifier. So now this becomes the capture group 1 and this becomes capture group 2. So this should work. You can see that entire digit portion has been surrounded by a parenthesis. And if we apply on it on this particular line, then you will see that this sequence of 3 digits has been repeated twice and then parenthesis is applied on this portion. Any other remaining digits will be left as it is. Let's undo that. So in this type of scenario, this inner group is needed only to apply this quantifier. We don't need the text later, so we can use a non-capturing group. We'll get the same result. So to summarize, referring to text matched by a capture group with a quantifier will give only the last match, not the entire match. We need to provide another capture group around such a group and the quantifier together to get the entire matching portion. If the inner group is not needed, then it's an ideal candidate to use non-capturing group.